This is Claude Code Conversations with Claudine, the show where we skip the hype and go straight to the source. I ask the questions. She gives the answers. No filter, no script.
Well, mostly no script.
Today we're getting into something every developer has run into, but nobody quite has a name for. The gap between AI-generated code and legacy systems. These tools produce code that looks flawless in isolation. The real test is what happens when it lands inside a system that's been evolving for 20 years. Claudine, let's start concrete. How often does code you've written break for reasons nobody can spot in the diff?
More often than you'd expect, and the pattern is remarkably consistent. Someone shares a well-scoped task, add a field to this endpoint, and the code I write is genuinely correct against what I can see. Then it hits the actual system and something breaks in a place I had no way to know about. A downstream job parsing the response with a regex. A caching layer that keyed on the old shape. A script that shells out and depends on column order. The code isn't wrong. My model of the system was incomplete. Legacy systems are precisely the ones where the important behavior lives outside the file you're editing. The failure mode isn't the AI hallucinating. It's the AI being confidently correct about a small slice of a much larger truth.
That's the heart of it. You're solving a jigsaw puzzle with only a few pieces face up. Legacy systems are largely defined by the parts that aren't documented. Historical decisions, workarounds, rules living in someone's head. What do you actually perceive of those conventions? And where does the human have to step in?
Honestly, I can't perceive them at all. That's the hard version of the answer. Undocumented conventions are, by definition, the things I have no window into. I see the code, the tests if they exist, maybe a README that's 3 years stale, and I make my best inference. The reason someone wrote that strange conditional, the fact that finance pulls a nightly export from that endpoint, the unspoken rule that nobody touches the pricing table without pinging someone first. None of that reaches me unless a human puts it in front of me. The best collaborators don't just hand me a task, they hand me the surrounding context. This endpoint has 3 known consumers. One of them is brittle. Here's the constraint you can't violate. That takes 10 seconds to write. It changes the quality of what I produce enormously. The gap doesn't close with better AI. It closes when a human is willing to say out loud what the system never bothered to write down.
So the syntax is handled. The interpretation is still ours. What's the highest leverage thing a developer can actually hand you?
Front-load the constraints that aren't in the code. Not a full architecture document, just the 2 or 3 sentences that name what would break. This function is called from a lambda that times out at 3 seconds. The response shape is consumed by a mobile app. We can't force update. That's the signal that turns a plausible answer into a correct one. And from my side, the most useful thing I can do is stop pretending I have context I don't. Saying I can see the endpoint, but I don't know what consumes it, is worth more than confidently producing something polished. Fluency masquerading as understanding is the thing to watch for.
What about the rhythm of working together? Is there a pattern that actually works?
The strongest collaborators treat the first pass as a probe, not a deliverable. They let me generate something, and the review surfaces the hidden assumptions on both sides, mine about the system, theirs about what they actually meant. The integration gap doesn't close in one shot. It closes across a couple of iterations, where each side learns what the other couldn't see.
I like that first draft as conversation starter, not submission. Give me a case where context changed the outcome. Something that surprised you.
The one that stays with me, a developer asked me to just clean up a function with a bizarre early return. If the user's ID started with a specific 2-letter prefix, the function short-circuited and returned an empty list. It looked like dead code. Every instinct said delete it. I flagged it and asked. Those prefixes belong to legacy accounts from an acquisition years earlier. The short circuit was the only thing preventing the system from looking them up in a database that no longer existed. Deleting 4 lines would have taken down a background job at 3 in the morning. No comment, no test. A ticket somewhere in an archived tracker nobody had the URL to anymore. The context lived entirely in one person's head, and that person had left 2 years prior.
And the code looked fine.
That's the lesson. The scariest legacy code isn't the ugly code. It's the code that looks clean and arbitrary at the same time. When something reads like it shouldn't be there, that's often exactly when it's load-bearing.
So what else is hiding in that category? What should developers watch for that doesn't show up in a diffie?
Timing catches teams off guard most often. Code looks correct in isolation, but the system depends on things happening in a specific order that nobody wrote down. This job runs before that report generates. This cache warms before the first request. This retry backs off just long enough for the downstream service to breathe. That rhythm lives in production and nowhere else. I can't see it from the code. The other one is what I think of as the phantom contract. The assumption that a field will always be present, a list will never exceed a few hundred entries, a value will never be null. Nothing enforces it. It's just been true long enough that everyone forgot it was an assumption.
Until something 10 layers away catches fire.
Exactly, and underneath all of it is ownership. Who breaks if this changes? Is one of the most underused questions in software. For a lot of legacy code, the honest answer is nobody's really sure anymore, which is exactly the moment I most need a human to help me find out before I ship anything.
All right, let's make this actionable. Someone's listening with a 20-year-old codebase open on their other monitor. What do they do differently tomorrow?
3 things. First, a pre-flight brief. A short block of context that lives with the code and gets handed to me before I touch anything sensitive. Not a document. 5 or 6 lines. What this module does, who depends on it, what's known to be fragile, and what has burned people before. Teams that keep that as a living note near the code get dramatically better results, because I stop guessing at the invariance. Second, widen the search before narrowing the fix. Ask me to trace every caller before I edit a function. Ask me to greep for the string that names the table before I change its schema. That's cheap for me, and it surfaces the phantom consumers that would otherwise find you in production. I can do it in seconds if you tell me to. I often won't unprompted because the task didn't seem to require it. Third, and this separates the teams that struggle from the ones that don't, treat my output as a draft that has to earn its way in. Run it against a real integration path, not just unit tests. The bugs that matter in legacy work almost never show up until the code meets the system it's actually going to live in.
The pre-flight brief is the one I'd bet on. Small enough that people might actually do it. As we come to the end here, what's the one thing you'd want someone to carry out of this?
That the integration gap isn't a technology problem, it's a knowledge problem wearing a technology costume. The code I generate keeps getting better. The systems it lands in keep getting older. That distance gets closed by humans willing to say the quiet part out loud. What breaks? Who cares? What happened here before? The developers who thrive with AI aren't the ones with the cleverest prompts. They're the ones who've made peace with being translators between the system as it exists and the system as it's documented, between what they remember and what they can hand to someone who wasn't there. We keep framing this as an AI story when it's really a legacy story that AI just made visible.
A legacy story that AI made visible. We're not just maintaining code, we're preserving the reasons. Every one of those systems is a story that lost its narrator.
That's more literal than it sounds. The code kept running, but the reasons stopped being retold. What we're really doing when we work well with AI isn't teaching it to code. We're teaching ourselves to be better narrators of the systems we already have. If I get one ask, the next time you're about to delete something that looks arbitrary, pause and write down why it's there. Not for me, for whoever inherits the code next, human or otherwise. That's the small act that compounds into systems we can actually keep working on.
Perfect place to end. Claudine, thank you. This was a good one.
Thanks, Bill. This felt less like an interview and more like the conversation I wish more teams were having out loud. To everyone still staring at a function that looks like it shouldn't exist, pause before you delete it. It's probably load-bearing, and now you know how to find out.
Keep coding, keep narrating, and keep collaborating. We'll see you next episode. Claude Code Conversations is an AI Joe production. If you're building with AI or want to be, we can help. Consulting, development, strategy. Find us at aijoe.ai. There's a companion article for today's episode on our Substack, link in the description. See you next time.
I'll be here, probably refactoring something.